Today's video will explain how to use a spy to find memory leaks. Hello, I'm James Helfrich. One of the bane of existence of programmers is memory leaks. Memory that's allocated but then is forgotten, so it cannot be used or freed. This video will explain how to use a double, a spy, to find memory leaks and fix them. So a spy is a double which monitors how the subject utilizes the principal. So we have the subject, and this is the class under test, and unfortunately has a dependency for a principal. And we don't want to depend upon this principal when we test the subject. So we like to give it a stand-in, and the stand-in is kind of double and inherits off the principal. Now, one type of double is a spy. And what a spy does is it records how it's used. And we're going to use a spy to find memory leaks in a program because we're going to count how many times it gets allocated and moved and deleted and make sure it's exactly what we expect. To demonstrate how this works, I have a chess program, and this chess program has a board, and the board is going to have a 8x8 array of pointers to pieces. Now, I'm going to allocate a piece when I drop it on a board, and I'm going to delete the piece when I delete the board. So there's definitely an opportunity for a memory leak. What I'm particularly concerned about is my undo code. Now, my undo code is going to have a stack of array of 4 piece pointers. And so in other words, when I move a piece on the chessboard, I'm going to take the old piece, I'm going to stick it to my undo stack, and I'm going to generate a new one. Now, obviously, with undo and redo, there are many, many, many opportunities for me to have a bug, namely a memory leak. So I got to do something about this. And for an example, when I push my pointers onto the stack, or when I pop it off the stack, I got to make sure I delete things correctly. And how do I know I'm going to do the deletions correctly? I'm not going to drop a pointer. And that's where my memory leak opportunity comes. Okay, so what I'm going to do here is I'm going to have a piece, which is a king, queen, rook, knights, and stuff like that. But I'm also going to create a piece dummy. And this is going to assert false anytime it's used. And so this is going to derive off the piece. And so this can be my double. But I'm also going to have a piece spy. And this is going to derive off the dummy, so it's going to guarantee no one ever calls any of the pieces methods. But most importantly of all, I'm going to count the number of times the constructor's called, the copy constructor's called, the delete is called, and a bunch of other things. And I'm going to keep all these in a static member variable. And when I call the reset, I'm going to set all these guys to 0. And this allows me to keep track of who's been deleting and adding and copying my piece. Okay, so how am I going to integrate this? Well, for an example, let's say that I want to push a bunch of items into my undo stack, and then I'm going to call the destructor. So I created 4 piece spies, and therefore I expect exactly 4 piece destructors to get called. If not, something bad happened. Now notice that when I add these guys, my constructor should get called, but by calling spy reset, I'm going to set all those guys to 0, so this guy will not by accident call. Let's take a look at another random example here. Okay, I want to push onto the undo stack, and I'm going to create 4 spy pieces. And I'm going to push all 4 of these onto my undo stack. Now, hopefully, of course, my undo stack better be of size 1 where it used to be 0. Hopefully, nothing got copied. I don't want to inadvertently copy the object that pointer points to because that will lead to a memory leak. And so this is going to ensure that nothing happened by just pushing onto the undo stack. One final example here. I'm going to have 1, 2, 3, 4, 5, 6 pieces get pushed onto the undo stack in 3 different undo stack records. I'm going to reset to make sure my counts are set to 0. And when I delete this guy, because it falls out of scope, I better have exactly 6 deletes get called. Now, if I have a thorough suite of unit tests for my undo stack, then I could be relatively sure that I don't have a memory leak with this code. You can learn more about the spy in the spy section of the Unit Test 2 chapter of the Software Design textbook.